Hello guys, welcome in my video. In this video our topic is introduction to registers. As in my previous video I have given you introduction to registers by names only, but today in this video I will give you a little introduction to the working of those registers that I have tell you in my previous video. So let's start our today video without any further delay. So here is our lecture 3. Lecture 3 is introduction to registers with working. So let's begin it. So here we have accumulator register. This register is used to perform basic mathematical and logical operations. So here a question come in our mind: what is basic mathematical operations? Basic mathematical operations, you can say that addition, subtraction, multiplication and division, these are basic mathematical operations. We can perform these basic mathematical operations with the use of accumulator register while doing coding in assembly language, and some logical operations. Logical operations including input, output. You can take input from user. With the help of this register you can display output on screen with the help of this register, and some other operations you can perform while using this register. These kind of operations I will show you while doing coding in assembly language in our upcoming videos. If you want to learn assembly language, you have to watch all my videos, because this is a basic of assembly language and these basics will be used in our upcoming videos. Our upcoming videos will be based on coding. So accumulator register basic symbols is AX, EX, AL, AH. So these symbols also depend upon the size of variables. So what is size of variables? You can also know this topic in my upcoming video. And after that, the base register BX, used for indexed addressing. It is used to store the value of the offset. What is offset? I will show you while doing coding. Its symbol is BX, and you can also say EBX. EBX in terms of the size of the variables we initialize in assembly language. And then counter register. Counter register, you can say, used to store the value of the loop in assembly language. If you don't know what is loop, I will teach you. And if you are doing any kind of programming, that is C++, Java, Python, etc., then you are surely familiar with loop. So counter register is used to store the value of loop. Its symbol is CX, and then we are having destination register DX. It is a data register used to store data on RAM. Its basic symbol is DX, EDX. EDX in terms of 8-bit, you can say that size of register. All register symbols, all basic general purpose register symbols is depending upon the size of the variable that we initialize during our assembly language programming. Okay. So next we are having segment index. It is used in the pointer addressing of data and as a source in some string related operations. Its basic symbol is SI, ESI. You can say that while displaying string on screen, we can use this register segment index. Then after we segment index, instruction pointer. Instructions next to be executed are stored in this register. And PSW register. PSW register stands for program status word register. It is a collection of 8-bit register, different 8-bit functionality. This register is used to perform different 8-bit functionalities. And then we are having stack pointer. Stack pointer used to store the top value of stack in the form of binary numbers. Basically, stack pointer is used to store the top value, that is, you can say that the first value of stack, and this can store this value in the form of binary numbers. Okay, the next we are having a base pointer. Base pointer is used to store downward last value of stack. It is will also store this value in the form of binary number. And then stack segment used to store the initialized variables. The variables which we initialize while doing assembly language coding will be stored in stack segment. And extra segment when stack segment is full after initializing variables. You can say that extra segment will use when stack segment is full. You can say that the memory of stack segment is full by initializing variables, and after that remaining variables will be stored in extra segment. And then code segment, a part of assembly language program where main program is written. You can say that the all assembly instructions in written in this portion. And data segment, a part where data is initialized. You can say that variables is initialized. Processor can fetch data from this segment, and initializing is happening in this segment. So that's the working of our 14 registers. Thanks for watching. Don't forget to subscribe and press the bell icon.